Here's an electric water heater for the sink. It is made by ThermoMate. The model is ET037DE. The device itself looks like this. The size is pretty small. The power consumption is 3.5kW watts. So my power source is also rated for 16 amps. So don't use too thin cables. Temperature range 30-45 degrees Celsius, so it is not heating up the water too much. Switch on flow rate 2 liters per minute, so below 2 liters per minute it will not even turn on. The weight is pretty low, you can easily transport it, and the size is quite small. It's inside a nylon and it has a manual. Here we have some gaskets and screws for mounting it, and the device itself is this. It's quite small, the size is roughly as my hand, 400-ish kilowatt hours per year. It has a digital display, which is this one. 2 buttons, they cannot be pressed, so they have to be touch buttons. That's the back side, 2+1 connectors. It should have a dedicated circuit breaker. One on the right is the cold water and the one on the left is the hot water. We have the neutral and the line, a temperature limiter. It has water flow sensor, outlet water temperature sensor and inlet water temperature sensor. A triac, the switch which powers on the electricity for the heater element. ThermoMate upside down, so I guess you can mount it in any direction. You can remove these. They have a rubber inside. If I blow air in on one, the air exits on the other one. Nothing is blocking the airflow. On the left side we have some other details. Model 6 bar, 16 amps, 52 degrees Celsius is mentioned here. The cable itself is quite short, around a meter, 220 volts, 16 amp is mentioned here also. Those are the 2 connectors. This is for securing it. We have 2 screws here, just in case you want to take it apart. The blue has a mesh inside. I see, maybe that's a sensor, temperature sensor. Now let's try to connect it. So in this case, that's the cold water and that's the hot water. I will connect it to the cold water, 3/8 of an inch. Full of water inside. So this hose goes up to the tap. I will connect another hose which has 1/2 inch connector here, and I have a reduction. This has a rubber inside, so that should seal, that black one. So that's the output. Let's connect it here to the red. And that's the water inlet. Electricity is not yet connected. Enable the water. Water entered into it, got pressurized. Water is coming from this one, going through the heater, and it's going up there to the tap. On the right, that one is shut off, so I should have only cold water from the left. By the way, here is the watt meter. This is also 16 amp rated. I will be using it at the maximum capacity, which is not too good. Power it on. Display turns on. 0.9 watts. So nothing is happening yet. I see lines there, no number. Now let's see if I release some water, what will happen. Nothing. So just by releasing water, nothing is happening here. The hose is visibly moving when I shut off the water. That's the water hammer effect. That movement of the red pipe hose. I don't feel any electricity, luckily. It's a touch button. 33 is visible there. Now 16. If I touch it again, it is off. 33 and it returns to 60. So probably the current temperature of the water is 16 and it's set to 33. It's 1.1 watts instead of 0 point something. So if I power it off, it goes to 0.9 watts consumption. Let's see what will happen. 3000 watts. And yes, it's getting somewhat warmer. I'm splashing the water, that's not good. The flow rate is not too small, that's at 22. And it's not increasing too much. Let's reduce the flow rate. What will happen? Now it's getting, yes, it's warmer. Ooh, it's warm. If the flow rate is high, then it cannot heat up the water. It's warm to the touch, so you can definitely use it for cleaning. And it's consuming 2200. So if I increase the flow rate 3000, it's consuming more. Reduce the flow rate, that's a little bit too small. Yes, 1 watt. So you need a little bit of flow. There is no power consumption and it's already colder. A little bit more. Now we have 3000 watts and it's getting warmer. The circuit breaker did not jump, we still have power. And we have water. Okay, so it's working right away. So don't mix up water with electricity. These cables should run somewhere else, but it's definitely working. Sincerely, I barely read the manual and it's already usable. So it's kind of plug and play. Currently I'm getting the water from the cold water. So if this is turned off, then I have cold water on the left side where we have blue. If the other heater is turned on, then I should have warm water and warm water. But if I turn off this, then I have warm and cold. So first impression, thumbs up. Now let's see this one. So 30 is the minimum and 45 is the maximum. And it should accept it. That's the current temperature of the water in the hose, I guess, 29 degrees. So if it's not used, then that should drop back to around 16. It's consuming 1.2 watts. While not doing anything, release the water. Numbers are moving there. It's also consuming 3200, just as before. It's getting somewhat warmer. It says 25 and it's not increasing. Let's reduce the flow rate. 6, 7, 8, 9. Now I can feel it with my hand. Power consumption is 3300, 38 degrees, 9. It was set to 45 and now it's at 39 and it will not go higher. So you have to use a low flow rate in order to get that temperature. And it's not going up to more. Let's reduce it a tiny amount more. Maybe it will shut off. Yes, it went down to 1 watt. So you have to guess where to turn off the tap. So by releasing water, the consumption increases. By shutting off the water, it is automatically stopping. I kinda like it. This is still functional. It didn't welded. This did not melted. Nothing is warm. Well, that's a very good sign. Nothing is warm. Let's see the other end of the cable. This one. Nothing. No heat. Very good. So I like it. It's kind of plug and play if you have the right connectors. So power off from here, power on from here. And now I didn't have to power it on from there. So you can definitely wash yourself with this temperature. It's highly comfortable, it's not burning at all, and it's not cold. So this temperature, that 40 degrees, is very good. tankless water heater. So you are not storing the water. Of course, if there is no electricity, then you don't have any heating. Water heaters which have a tank, those have an advantage in this case, because if there is no electricity, then they already stored up a quantity of hot water and you can use that one. This does not have a tank, so if electricity is out, then you don't have any backup. But since it's not storing the hot water, it doesn't need any power to constantly heat it up a little bit because of the heat losses. So it's kind of more economical, I guess. But of course you cannot use multiple taps for this heater. This is usable only for one single tap, and even there at the lower flow rate. So that's a disadvantage. If you have another tap, then that should have another heater like this. And 3000 something multiplied by 2, you need a serious electric connection. You should not insert two such heaters in an extension cord like that. It will not keep up. It might melt, so it's kind of dangerous. So currently the power meter is rotating at this level, and now the heater is on. It's rotating much faster. There's another extension cord, and this one is rated to only 2200 watts. So this should not be used on that heater, which requires at least 1000 watts more. Power it on again. And the temperature should increase. 14, 15, 18, 19, 20 degrees Celsius. $30, roughly identical there also, 31. And if you reduce the flow rate a little bit, then it's getting warmer. 38 degrees Celsius water temperature, 40 degrees, 40 something here, 43 here also. And now the metal connectors are a little bit warm. Yes, indeed, they are not cold. So they do warm up a little bit. Almost 4000 watts is not a small amount.